Mr. Brown Secondary Science. Today we are going to have a go at nuclear equations. Now, nuclear equations can sound something a bit scary, a little bit, oh my god, how do they work? But don't worry about it. Once we've gone into the detail, you'll see they're quite straightforward, and you just need to remember a few basic rules to make sure that they work every single time. So, looking back at previous work, we know that there are three types of radiation. You have alpha, you have beta, and you have gamma. Now, gamma radiation we don't need to worry about for this. Gamma radiation is an electromagnetic wave. It is not a particle, so it is not something we need to worry about for balancing these nuclear equations. And apologies if you hear a small child in the background, that is my daughter. She is quite alright, she's just playing and being a little bit inquisitive as to what I'm doing. So, gamma is a wave. You don't need to worry about this for here. We need to worry about alpha and beta particles. Now, as we know from our last lesson, alpha particles are made up, and we'll move to the section here, alpha particles are made up of 2 protons and, I'll go for the right colour, 2 neutrons. That means that they have a mass of 4, but only 2 of those particles have charge, obviously the protons, so they have a proton number at the bottom of 2. Now, beta particles, they're not made up of either protons or neutrons, they're made up of electrons, and that means that they have no mass, but they do have a charge of -1. So whenever you write an alpha particle, you'll have your alpha symbol, you'll have 4 at the top for its mass, and you have a 2 at the bottom, which is its proton number. And then when we have our beta particles, it will have 0 as its mass, and at the bottom you will have a charge of -1, where the proton number would normally be. Now, the equations themselves, the bits that we look at and go, I don't get it, they're fine. They're fine. All they say is the elements that we start with, any element that can decay via nuclear radiation loss, there is a new atom formed. It's losing either protons or neutrons or electrons, so you are getting a new atom forming, and because it's decaying, it's releasing a radiation particle. You're going to have a radiation particle at the end as well. So, looking at the questions I've given to you, the first question, and we'll go through it in its entirety. It says americium 241 decays via alpha emission. It's decaying via alpha emission. So we know americium 241, which is right here. We know it decays via alpha emission, which is right here. And we can see that we've gone from americium to this new atom. This new atom which will form when the old atom decays. Now, as this is an alpha particle that is decaying, this americium gives off the alpha particle, creates this. We can see at the top we have lost 4 of the mass from the americium. So we now have a mass in our new atom of 237, and at the bottom we are losing 2 protons from the americium. So it goes from 95 to 93. It's just minusing 4, minusing 2 when you have an alpha particle. And at the end here you have your alpha particle, the alpha symbol, the 4 at the top for the mass, and the 2 at the bottom for the charge, or the proton number. So it's got a charge of +2, as you would find with 2 protons. Now that's alpha, great, but what about beta emissions? So beta emissions, I've written the question out again, and it says carbon-14 decays by beta emission. So beta, again, in the same way, we need a radiation particle, and that is what we have here. The beta symbol, no mass, so no mass number, but a charge of -1. -1. So, as you would expect in a similar way, for the mass number, because beta particles do not have mass, that stays the same. But at the bottom, -1, we're actually losing an electron, which means that we need to add a proton at the bottom here. So the proton number goes up by 1. So that's the rule. For alpha particles, you -4 from the mass number and -2 from the proton number, and you get your new element with that mass number and that proton number. And for beta particles, you always keep the mass number the same, 14 here, 14 here, and you add 1 to the proton number. So that gives us 14(7). And you must always have your radiation particle at the end. Alpha with 4 and 2, and beta particle with 0 and -1. To make it absolutely clear, that shouldn't be a 0, that shouldn't be a negative there, that is a +2. Any further questions on this? Let me know. In the second video I will be going through some examples. Thank you.